Have you ever been working on something important and your computer screen just freezes? For a split second, there's a strange digital artifact, a flicker of corrupted color, and then the system reboots. A moment of digital chaos, a brief, frustrating disconnect from your world. Now, imagine that happening to reality itself. Imagine the entire universe stuttering. A single, impossibly powerful particle strikes the top of our atmosphere, and for an instant it creates a cascade of energy so vast and complex it looks like a glitch in the fabric of space-time. A system-wide reboot protocol initiated by an unknown source from the deepest, darkest corners of the void. We are going to explore a real cosmic event that looked just like that, a moment when the universe revealed its own chaotic, unpredictable code. And in understanding it, we might find a new sense of awe and a strange kind of peace in the beautiful, complex machinery of the cosmos. Before we journey to this cosmic glitch, we must first understand the messengers that carry these strange warnings. They are called cosmic rays, but the name is a little misleading. They aren't rays of light, like starlight or X-rays. They are physical things, protons, atomic nuclei, tiny subatomic bullets stripped of their electrons and fired across the galaxy, across millions of light years of cold, empty space. For a long time, we didn't even know they existed. It wasn't until the early 20th century, when physicist Victor Hess ascended in a hot air balloon, that we discovered this invisible rain. He found that the higher he went, the more radiation he measured, proving it was coming from above, from space. Most of these particles are relatively low energy, shot out from our own sun, but a rare, powerful few come from distant, violent event, like exploding stars, and then there are the others. The ultra-high energy cosmic rays, ghosts in the machine, particles that carry the kinetic energy of a baseball thrown at 100 miles per hour, all packed into a single, invisible, subatomic point. They are the rarest and most mysterious phenomena in the known universe, and one of them is about to challenge everything we thought we knew. Our story begins in the high desert of Utah. Here, under a vast, silent sky, lies an extraordinary instrument, the Telescope Array Project. It isn't a telescope in the way you might imagine. There are no lenses or mirrors pointed at the stars. Instead, it is a grid of over 500 detectors spread across 700 square kilometers of empty land. Each one sits in quiet patience, waiting. They are not looking for light. They are waiting for a ghost to touch our world. For decades, these silent sentinels have monitored the sky, recording the faint signatures of cosmic rays hitting the upper atmosphere. Most of these events are predictable, understood, catalogued. But on May 27th, 2023, something different happened. A signal arrived that was so powerful, so energetic, it stood out from the noise like a scream in a library. The data flooded the system, painting a picture of an event that, according to the laws of physics, should have been almost impossible. The scientists who found it named it Amaterasu, after the sun goddess in Japanese mythology, a fitting name for a particle that seemed to descend from the heavens itself, carrying an energy that bordered on the divine. It was a single point of data, a single impact that would send ripples through the entire field of astrophysics. The desert had caught its ghost. Now the true mystery was about to begin. Where in the universe did it come from? To understand the shock of the Amaterasu particle, we have to talk about a cosmic speed limit. Think of intergalactic space not as perfectly empty, but as being filled with a very thin, very cold fog. This fog is the cosmic microwave background, or CMB. It's the faint, leftover heat from the Big Bang, and it permeates everything. For a particle traveling at near the speed of light, this fog is a formidable obstacle. Pushing through it is like trying to run through deep water. The CMB photons constantly collide with the particle, stealing its energy, slowing it down. This effect creates a theoretical energy cap known as the Greisen-Zatsepin-Kuzmin limit, or the GZK cutoff. In simple terms, any ultra-high energy cosmic ray from a very distant galaxy should have lost most of its energy by the time it reaches us. It should arrive tired, weakened by its billion light-year journey. The Amaterasu particle ignored this rule completely. Its energy was measured at 244 exaelectron volts, a number so large it's difficult to comprehend. It is tens of millions of times more powerful than anything we can create in our most advanced particle accelerators. It was traveling so fast and hit with such force that it seemed to have completely bypassed the universe's natural speed brake. This is the central paradox. A particle this powerful could not have traveled from a distant galaxy. It must have originated from somewhere relatively close, yet when astronomers pointed their telescopes in the direction it came from, they found nothing. So what happens when an impossible particle finally ends its journey? It doesn't simply land. When a UHECR, like Amaterasu, strikes a nucleus in the upper atmosphere, it unleashes a cataclysm. The initial impact shatters both particles, creating a burst of new, highly energetic secondary particles. This is just the beginning. Each of those new particles then smashes into other atmospheric nuclei, creating yet more particles, which in turn collide and create even more. This is the phenomenon known as an extensive air shower. It is a chain reaction of unimaginable scale. A single, invisible proton triggers a cascade that can grow to contain billions of particles, electrons, positrons, muons, and photons, all raining down towards the surface in a vast pancake-shaped swarm that can be miles wide. This is the glitch in our cosmic system. From the ground, it's completely invisible to our eyes. But to the detectors of the telescope array, this shower is what they are built to see. As the particle storm sweeps over the desert, each detector it hits records a tiny flash of fluorescent light, a faint Cherenkov radiation signature. By measuring the precise timing and intensity of these flashes across the entire grid, scientists can reconstruct the event. They can trace the shower back to a single point in the sky, calculate the energy of the original particle, and paint a picture of the impact. The air shower created by the Amaterasu particle was enormous, covering an area of nearly 50 square kilometers. It was a fleeting, silent storm of energy. A momentary reboot of a tiny patch of our planet's atmosphere, triggered by a single, mysterious visitor from the void. We began in the silent desert of Utah, and we journeyed to the edge of known physics. We followed the trail of a ghostly particle, one that carried impossible energy from a direction that should have been empty. A particle that, upon arrival, created a beautiful, chaotic storm in our atmosphere, a momentary glitch in the system of reality. The Amaterasu particle is not an error, it is a message. It is a profound and humbling reminder from the cosmos that the map we have drawn of existence is still largely incomplete. There are forces and objects out there that we have not yet imagined. This cosmic reboot isn't a sign of failure in our understanding, but an invitation to explore further, to ask bolder questions. The universe is not a static, predictable machine. It is a living, breathing, evolving entity, still full of secrets. And perhaps that is the most comforting thought of all. Thank you for joining us on this journey to the edge of understanding. These cosmic mysteries remind us that the story of the universe is still being written, and we are lucky enough to be able to read its pages. What do you think is the source of these impossible particles? Share your theories in the comments below.